Assalamu alaikum. Myself Dr. Ansari Farzana Veduzama, Department of Chemistry, J.A.T. Arts, Science and Commerce College for Women, Malegaon. Welcome all of you. Now today we will start section 2nd of the Physical and Analytical Chemistry second term CH401 Conductometry. It is a very interesting chapter. Before going the deep study of conductometry, we must know what is meant by electrolyte and non-electrolyte. Substance can be classified as electrolyte and non-electrolyte on the basis of ability of their aqueous solution to conduct electricity. The electrolyte are the substance whose aqueous solution conduct electricity. The electrolyte also conduct electricity when fused. The non-electrolyte are substances whose aqueous solution do not conduct electricity. According to Arrhenius, an electrolyte when dissolved in water or when fused dissociate partially to give ion, cation, positively charged, anion, negatively charged. For example, electrolyte AB dissociate partially as AB in equilibrium with A plus and B minus, and equilibrium exists between the dissociated and undissociated fraction of electrolyte. The total positive charge in the solution is balanced by total negative charge. The solution is therefore electrically neutral. Under the influence of applied electric field, the ion move towards the oppositely charged electrode. This movement gives rise to conductivity to the solution. The electrolytes are further classified as a strong electrolyte and weak electrolyte, depending upon the extent to which they dissociate in dilute solution. The strong electrolyte dissociate almost completely in dilute solution. A weak electrolyte, on the other hand, dissociate partially in such a solution. Quantitatively, the ability of solution to conduct electricity Quantitatively, the ability of the solution to conduct electricity is expressed in terms of its conductivity. The conductivity or conductance of solution of electrolytes is found to be dependent on the factors: the nature of electrolyte, the concentration of solution, as concentration decides the number of ion in the solution, the velocity with which cation and anion move in the solution, mobility, that means mobility of ion, temperature, temperature decides the mobility of ion and also extent to which weak electrolyte dissociate. In this chapter, the conductivity and other related topic will be discussed. We must know what is meant by Ohm's law and electric unit. Ohm's law and electric unit. For any metallic or electrolytic conductor, the strength of electric current flowing through conductor, the resistance of the conductor and potential across the conductor are related to each other by the relation I is equal to E upon R. This relation is called Ohm's law. According to Ohm's law, the current flowing through the conductor is directly proportional to applied electromotive force and is inversely proportional to resistance offered by the conductor. Based on Coulomb's law of force between electric charge, the electrical unit can be expressed in CGS in electrostatic unit. Electrostatic unit ESU. The ES unit are not of a convenient magnitude for experimental purpose. Hence, practical units have been defined. The unit in international system are international ampere for current, international volt for difference of potential or EMF, and international ohm for resistance. The international ampere is defined as the quantity of electricity which flowing for 1 second will cause the deposition of 1.11800 milligram of silver from solution of silver salt. The international unit ohm is the resistance at 0 degree C of a column of mercury 106.3 centimeter long of uniform cross section weighing 14.4521 gram. The international volt is the difference of electrical potential or EMF required to maintain a current of 1 international ampere through a system having a resistance of 1 international ohm. The unit quantity of electricity is international coulomb. The unit of quantity of electricity is international coulomb. It is the quantity of electricity passing when 1 ampere flows for 1 second when a current of strength L passes through the resistance cross which the potential drop is E. For T second, the electrical work is given in joule by Joule's law as W is equal to E.I.T or this is equal to EQ, where capital Q is equal to IT. 1 joule is the amount of work performed by the current of 1 ampere flowing for 1 second under potential drop of 1 volt. The electrical power can also be expressed in terms of watt. It is the work performed at the rate of 1 joule per second. P is equal to EI and this is equal to EQ upon T. Electrolytic conductance. The passage of current in case of metal, which are supposed to be the best conductor, is not accompanied by transfer of matter, but exclusively due to electron under the influence of applied potential. In case of electrolytic conductor, on the other hand, the transport of electricity is entirely due to actual transfer of matter, that means ion. This transfer results in the change in concentration and there is accumulation of material at the point where the current leaves or enter the solution. Now consider the mechanism. In order for electric current to flow through the electrolytic solution, the current must enter or leave by metallic conductor. These are known as electrode. The current enter the electrolyte through anode and leave the electrolyte through cathode. In this figure represents a system containing anode and cathode dipped in electrolyte solution. As has been already mentioned, the transport of electric current through an electrolytic conductor is due to ion carrying either positive charge or negative charge. The cation move towards the cathode and anion move towards the anode. When current is flowing, Now, what is mean by specific resistance? The resistance, specific resistance is denoted with the help of letter rho. The resistance of any conductor having uniform cross-sectional area is found to be directly proportional to its length and inversely proportional to its area of cross-section. Therefore, R is directly proportional to L to inversely proportional to A. In order to omit the proportionality constant, it becomes R is equal to rho L upon A. The proportionality constant rho is called a specific resistance of conductor, and capital R is expressed in ohm. This equation is applicable to all conductor, electronic or electrolytic. On rearranging this equation, we get if A is equal to 1 centimeter square and L is equal to 1 centimeter, then rho is equal to R into A upon L. Then R is in ohm and area is in centimeter square and length is in centimeter. So centimeter नीचे का और सेंटीमीटर ऊपर का गेट्स कैंसल, बचेगा क्या? ओहम सेंटीमीटर. The value rho is characteristic property of conductor and depends upon the nature of conductor. A specific resistance is the resistance offered by a material 1 centimeter in length and having area of cross section 1 centimeter square. Thank you for watching.